We have our second speaker of the day, Jorge Barreto. So Jorge is a lecturer and the interim CDT director for the quantum engineering CDT. He completed his PhD in light emission from silicon nanocrystals. He joined the University of Birmingham as a research fellow and worked on size-selected metallic nanoparticles, atomic probe characterization techniques, and ultra-fast light matter interaction processes. In 2012, he joined the Quantum Photonics group at the University of Bristol, which is now known as CET Labs, and has been leading the effort on low-temperature quantum photonics. In 2016, he became a lecturer in the CDT and has been an integral part of it, helping to make it a great and fantastic place to learn quantum engineering. That was added by me. And today, Jorge is going to be speaking about managing your PhD research, from continual planning throughout to tips on writing a thesis and just generally managing yourself. I'm sure this will be a very informative and insightful talk for not only PhD students such as myself, but also for students thinking about looking into going into studying for a PhD. As with the previous talk, throw some questions in the Q&A if you have them, and upvote them if you think they're interesting. But yeah, without further ado, I hand over to Jorge. And yes, floor is yours. The Zoom is yours.
Thank you very much, Dave, and thank you for the Careers in Quantum committee. You're doing a great job, and I just want to acknowledge that. So let me start by sharing my slides. Hopefully that can be seen. So yes, I'm going to be talking about PhD life, and an example of why I consider myself experienced enough to be able to provide that information is, amongst other things, because I've been in academia for quite a few years now. And in general academia, you have plenty of students around. As an example, here's a picture of our current research group, the Quantum Engineering Technology Labs, and more than half of the people in that picture are PhD students. And from the remaining, most have been PhD students at some point in their life. So, for the talk today, I have these structures. So first I'm going to talk about a bit about myself, though they've introduced myself already. Then I'm going to briefly discuss all the decisions that go before starting a PhD. Then I'm going to talk about what is it like to do a PhD, some additional details, comments on the thesis, and finally what to do next, although Careers in Quantum is precisely targeting that last bit, so that will be brief. So, as Dev said, I studied in Spain at the Universitat Autonoma de Barcelona. There I did my undergrad degree in physics. That's a licenciatura, that's a 4-year degree. And then I did my PhD in the university, but as part of the research center in microelectronics. And again, it was on light emission and silicon technology. Following that, I went to Birmingham and Bristol. So one thing that I would like to highlight here is that I'm essentially an experimentalist, and I've been changing the topic of my research quite often, essentially in every new institution, and that has been quite an adventure. More about myself, I've supervised already 4 PhD students to completion. I'm currently supervising another 6. And I've supervised about a dozen undergraduate and master's projects. So I feel that I have, interacted with students enough beyond what the existence in the university environment gives me. Beyond that, I'm a human, and therefore I have some hobbies, amongst them football and photography. And back in the days, I used to spend time in the lab. Now I spend most of the time in the office, and that's a natural evolution of careers in academia, or pretty much any career that you specialize on. So let's start with the beginning. And the beginning for many is that trigger of the end of degree life crisis. This happens when you finish your degree and you've been studying for so many years in a structured environment and knowing your goals very clearly. You want to get a degree in something that you like. And it's always been easy and straightforward. So what happens after the degree? What do you do with your life? And it's funny because this is the same effect that you may experience before you start the PhD and after you finish your PhD, because after the PhD, there's not many things that you can continue studying on. And the PhD is not like an undergraduate degree, it's slightly different. However, in my case, it was fairly simple. I wanted to be this guy. I wanted to be a crazy scientist with a lab coat and some evil laughter. And in order to get there, popular culture told me that I needed to be a doctor, right? All the evil scientists in history in popular culture are doctors, and a doctor actually comes from Latin, it means teaching. Philosophy doctor means that you're able to teach at a very profound level. There's other considerations that come with a PhD, such as, especially if you come from physics, your range of employability, the range of tasks that you can do is pretty wide, and the salaries are not bad either. So there's many options for you after you finish your PhD. However, I wasn't that smart. I didn't care about that. I just wanted to be the crazy scientist. So in order to be a crazy scientist, you need the PhD, and in order to need the PhD, you need to go through a recruitment stage. The recruitment stage essentially allows you to start a PhD somewhere on something. So there's a few questions that you need to ask yourself first, beyond the motivation that you can have to do a PhD. And this is, first, where to find the information, where to find which projects are available, which supervisors are recruiting, which universities you can go to. And back when I was a student, there was not that much information, and we mostly relied on, talking to teachers that we knew and essentially networking at an undergraduate level, which is surprisingly important and probably still extremely relevant. Nowadays, we have plenty of resources online, and we can access lists of projects and lists of academics. But I have to say that academia is not particularly good at updating websites. So often the best solution is to do networking in person through the teachers that you know on the topics that you like. The next point here that is probably very relevant to people that are thinking about doing a PhD in the future is when to apply. And when I was a student, it was fairly easy. You would wait until the end of your degree, and then you would take your degree and go to Professor X and talk to them about the projects you want to do with them. Nowadays is slightly different, and the recruitment process actually starts much earlier. People tend to submit their applications around Christmas or after Christmas, with interviews happening in early spring. That means that you will be interviewing for PhD positions without knowing what your final grades are, or whether you actually like that final year project at all or not. And this is a bit of a inconvenience, but that's how the funding works, and that's how the recruitment process works. So you can wait. There's still some positions available in some institutions, but typically you need to apply very early. Then, in terms of types of positions, I should have renamed that into funding, because it really depends. The experience will depend on whether your funding comes from one source or another. There's obviously the extreme case of self-funding, which I strongly discourage since you're doing work. Your research is going to be valuable for someone, so I strongly discourage people to self-fund unless they really have surplus money. So if you don't have surplus money, which is the general case, you have several options. Either you go for a scholarship offered by some government institution, or you go for a scholarship from the university, or you seek an industry-sponsored PhD. In the last case, there's going to be additional IP considerations, and the first two tend to be fairly competitive. Once you know what sort of funding you're aiming to get, that should also affect when to apply. So you should explore well the spectrum of options that you have early on. The interview process is sometimes surprising for applicants, because the objective is not that much to test whether you know what you know, which is part of it, but also to test whether you have the right attitude to a PhD. A PhD is not like studying another year at university, your undergrad. It's a bit more convoluted and requires a different attitude. And that's something that will be explored during the interview, and you need to be prepared for that. Now, things that you should consider from my point of view, that most people do, is first of all the project, whether you're interested in studying that or exploring that area of research, whether that's first interesting for you, second aligns with your skill set, whether it is something that you see yourself doing in the future, not as relevant, but potentially yes. The second point is the supervisor or supervisory team, and these may lead to, I'll explain later in detail, but it is important that you get on well with your supervisor and that you see things in the same way. Many people also consider the institution. You prefer to do or students prefer to do their PhDs in institutions that are well known, because that enables them to have higher employability and on the long term. Although ultimately you can have a very successful PhD from pretty much any institution. The final consideration here is life quality. And this is the funny one, because you have to think that you're going to move to a city for 4 years of your life, and you should be able to balance whatever your funding is available with the life cost of living there, and the hours that you'll put into work, and the balance of not work that you'll be able to have outside that environment. So this is something that changes quite a bit between different places, and you should really consider what you want to do with your life outside academia while doing your PhD when making that decision. Also note is that often during the recruitment process, things may look very, very shiny and interesting and exciting, and then you can find later on that they were not as pleasant. And this works both ways, right? You're going to polish your CV, you're going to be ready for the interview to be really charming, but then maybe on a daily basis, you still have your typos and you don't shave every day. So in that sense, this is something that you have to acknowledge that will happen, and it's part of the process. So just don't be disappointed, and also don't be too excited about shiny things early on. Okay, there's a bonus round here that I did this morning, because I was thinking that it's really important, and people don't mention it often enough, and that is that success and luck in academia are very closely related. Very often you can have a very good set of skills, be a very hard-working person, but if you're unlucky, your PhD is not going to be as pleasant or successful as you would expect it to be. And likewise, you may be not the hardest worker and not the brightest person, but be lucky in the choice of projects and supervisor and environment, and therefore that's going to lead to a successful PhD, or what many consider a successful PhD. So some examples of things that can happen and you have to deal with and accept that they will happen is, for instance, if you're an experimentalist, the equipment may be broken, or there might be delay in access, and that is going to push your timeline of the project, and that's something that has to be prepared in the research plan, but it's something that needs to be taken into account. The science that you're researching might be published elsewhere, weeks or months before you finish yours, and that's a bit tragic, but it happens, and you have to be able to deal with it. The supervisor or the collaborators that you work with may change institution or change intentions, and therefore the balance of resources that you have is going to change. Or maybe you're going to find out that the research was actually impossible, or the outcomes were irrelevant for the field, and that is fine, because just part of what it is. On the other side, you may be joining an ongoing project and be at the right place at the right time and just start producing results from an early stage, and that will let you continue with a high level of success. You may be lucky and just find some funny effect early on, and that is going to open a new field of research just because you were testing something different, not because it was planned, but just because it happens. You can have, you can also join a reputation momentum, so essentially riding the wave of either the institution, the research group, or even just because it's a hot topic in research, and that is going to give you additional advantage. In essence, you have to be able to understand that, you know, it's not all hard work and, you know, personal ability to do the research. It's also a big element of luck, and that will carry on through your PhD. Okay, now what is it like? First, the science. According to university regulations, the challenge is to obtain a significant and original contribution to knowledge worthy of publication or dissemination in whole or in part in a form appropriate to the discipline. That means that you need to make that tiny little bit of extra knowledge, and that to be relevant to the others. That is the objective of a PhD. That's what you should aim to get at the end, something new, something that you have done. The tools you have for that is obviously the scientific method, so hypothesis and proof, some mathematical models, probably lots of coding, and plenty of scientific literature. You'll be spending loads of time reading, and you'll be able to have your scientific production peer-reviewed, which essentially means that other scientists will have their say in the quality of your output. Now, the distractions in general, from the scientific point of view, is that everything is awesome. When you start working in research, you're going to find out that your research topic is interesting, but there's also other research topics around it that are interesting. Your colleagues are going to be working on projects that are interesting, and it's very easy to spread yourself very, very thin and start working on multiple projects and trying to do a bit of everything without actually achieving anything in any of those. So concentrating on one single project or a discrete number of projects is key, and just paying attention to the spread of different topics is relevant from the beginning. So how to do that? Well, typically a PhD takes about 4 years, and you know, dates may vary, but in general, long-term deadlines are very hard to manage at first. You essentially, to keep working on one project for 4 years, you need to be able to break it down into different medium-term goals or short-term goals that you can achieve and focus on. But in general, you would experience the following, you know, timeline. First, in the first 9 months or so, first half of the year, you're going to be reading. You're going to be absorbing all the scientific literature, understanding what's the state of the art of the topic. Then you're going to get used to the resources, and that may be equipment, software, mathematical tools, essentially the tools you're going to use to do the science. Then you're going to start focusing on the task, what is the project, and define the main area that you're going to be exploring, and also considering the side projects that would be relevant for you. That is the story that is going to be your PhD. But also, it only happens at the end of the second year when you already know what the literature is about and you feel confident with the tools. So it's going to take some time to get up to speed. The next year is peak productivity. Third year is when you produce the results, when you understand things, and when you get excited about new things, which leads to new ideas and realizing that you don't have enough time to implement all these new ideas. And that's when you decide whether you want to have a career in the future in academia or go to industry. It depends on your balance of enthusiasm for the field, and ultimately that leads to the final months of the PhD, which will be concentrated on writing the PhD manuscript thesis. I'm saying here it takes about 6 months, but it varies, as we'll see later on. So the supervisory team. And there is a very interesting balance between, as we can see in this coming through, between what the supervisors expect and what the students expect. And in order to have a successful relationship, you need to balance that and reach a midterm point. Depending on the country and the institution, the supervisors are called either advisors, PIs, or directors. So it's a bit funny, but essentially it's the same person, is the person that is going to guide your research. And there is a wide spectrum of supervisors. There's anything in terms of attitude towards the students. There's supervisors that consider students essentially monkeys that, you know, act on their brains, or supervisors that consider students colleagues and, you know, equals, and therefore are happy to collaborate with them, but are not going to tell them what to do. That also relates to whether you're going to have a hands-on supervisor that is going to be with you in the lab, helping with the research, or a manager that is going to facilitate the resources for you to do the research and allow you to get a direction. There's also supervisors in terms of that are more or less engaged with the project. You may be driving the project yourselves, or you may be expecting the supervisor to drive the project, and it's not always the same amount of engagement, but that might be fine. Some people are happy with low levels of supervision, and some people really want to have that extra degree of support. The supervisor will essentially be responsible for providing you with the resources, and that is anything from hardware to networking. Access to labs, access to computers, access to mathematical tools, and access to expertise in terms of, you know, scientists that also work in the field and can teach you those tools that you're going to be using in your PhD. The supervisor will be responsible for supporting your plan, and we will be monitoring whether you do that correctly. And that's probably the bit that students that have already started are less keen on, because they're concentrating on the research and thinking less about the long-term vision. But again, this is something that has to be revisited every few months. One important thing, at least for me, is that a good supervisor or good supervisory team should have experience both in success and failure. You would like to follow a supervisor that has succeeded, so, you know, they can teach you how they did it. But you also should be interested in knowing, you know, what to do when you fail. And experience is probably the best route to work on that. Finally, the new norm is that typically universities have about 2 supervisors or more. And these grants additional support both in the scientific aspect, as the knowledge is wider, and logistics, as the access to resources is wider. This leads to the requirement of balancing both supervisors and being able to work in a team, but that's just part of the deal. So, and just be aware that usually, you know, things are changing, and now it's even more team-based work than before. There's an interesting article that I recommend people reading. This is the 10 ingredients for a successful supervisor-PhD student relationship, and I recommend that for both supervisors and students. It highlights essentially 10 points, which I've put here, that make this relationship successful. First, I'm going to go quickly through it. First, the fact that both the supervisor and the student should be equals. Everyone is smart, one has more experience, but it's easier or more fruitful to start at the same level. The supervisor should facilitate the inspiration and creation of ideas and the means to develop those resources. They should be monitoring the work, as I said, and they should be facilitating cooperation internally and externally. Encouragement is a great deal of what the supervisor should do, and that's in terms of motivation. And there should be a clear decision structure for discrepancies. There'll be cases where the student disagrees with the supervisor, but that has to be sorted out swiftly. There must be a knowledge transfer intention, and that is essentially that the supervisor should be willing to let the student know even more than they do. And there should be a support for professional projection, that is the future career of the student. And if all this works, ideally the relationship will last forever. And I think in my case that is true. I keep the contact with my former students and my supervisor still nowadays after quite a few years. So I do recommend everyone reading this article. It's pretty wholesome. So Other than the supervisor, you'll be surrounded by other members of the research group and the institution, whatever the university is. And working in a team or as part of an environment brings additional challenges, different from the ones that you had as an undergrad. This is mainly because you're going to be learning together and cooperating together, whilst before, you were doing your degree on your own, and maybe you had a team project, but it wasn't that relevant how much cooperation you had. Cooperation is very important at the PhD level. There's also competition, and that is when people are working on the same towards the same goals, and these must be sorted out at the supervisor level. So if you notice that you're working in the same area than some of your colleagues, please ask your supervisors to sort it out, because otherwise it's going to lead to a very negative environment. Another thing about academia is that you're going to be cycling your team every 4 or 2 years, 4 years for students, 2 years for postdocs. That means that you're going to meet lots of people that are going to be very cool because they work on the same things that you do and are interested in the same things, but they're going to eventually leave and probably spread over the world. To reiterate on that, this is probably going to be the smartest group of people you've met yet. These are the people that managed to be first in high school, get good degrees as an undergrad, and they're doing their PhDs now. So they've gone through the recruitment process as well. They're also very highly motivated for science, and this is not very easy to find, but motivated people that are also skilled presents a very thriving environment. There's also some degree of diversity, probably not as much as we would like to have, but probably more than you've experienced so far, especially because lots of students on postdocs will come from other cultures, other nationalities, in addition to the differences in personalities and attitudes within the scope of being extremely motivated for science and being a good student. There's also the social aspect. And this is probably one of the things you'll remember the most from your PhD time. There's some pictures of the social aspect of when I was a student. This is me DJing in a Christmas party and a bunch of parties that we organized with the students and postdocs in the group. Food with academics at different events and also students. So lots of social interaction and probably keeping some of the best friends in your life from this time. Now, briefly about how is it a week in the life of a student? Well, the first thing is that we have very flexible working hours. People tend to start at different times and tend to end at different times. Typically, you work more than the 40 hours that is a standard 9-to-5 job, but that depends on the person. You will have more than 3 meetings, so that's plenty of meetings. One with your supervisor, one with the project team, one with the group or faculty or school. And then you have one seminar about new science, and you read about 1 or 2 new papers every week. It also will change depending on whether your topic is a very active area of research or whether it's more theoretical experimental. But this is an average of what you would experience in a week. And it tends to get pretty busy, so it's important to try and get a good work-life balance at an early stage, because otherwise you're going to carry on working very, very hard later. And that may have an impact on your motivation. So the big thing about motivation is that probably at this point, solving problems make you happy. And that's a human thing, human feature. And you, as a potential PhD student, are probably very good at solving popular problems that you have with a known solution and a known method. So that's a good student. You taught a method, you taught a set of problems, and you're asked to do the same, and you're good at that. Now, a PhD, you'll have to try and solve an obscure problem that very few people understand or see the potential impact of. You'll hope to find a solution, and you will try all the known methods, and you may even develop your own new methods. But success is not guaranteed. It is very likely that others have successfully tried in the past, unsuccessfully tried in the past to solve this very problem, and success is not guaranteed. A PhD means you'll be trying something impossible or likely to be impossible, and you'll be failing a lot. Imagine how you feel when you solve the problem for real, this impossible problem. And now you have to accept that you'll only feel that way a handful of times during your PhD. because there's only a very small set of problems that you can solve. So you need to be motivated enough to get that spike of enthusiasm to carry you throughout, time of your PhD, and that's 4 years of lots of failure, because it's really difficult. And I'm going to use here Edison's quote, where he was, asked, if you failed 1,000 times developing the light bulb, how do you feel? And he said, well, actually, I developed an invention with 1,000 steps. So all these are required to get to the end. And that is the right attitude for a PhD. You need to be ready to fail multiple times to find the correct path. Another thing that is related to motivation is imposter syndrome. And this happens to everyone at all levels in academia, particularly in academia. And it can be illustrated in this picture. This is what you know. This is what you know. And suddenly you have the impression that what the others know is so much more than that. But in reality, it's closer to this. Different people have different expertise, and there might be some overlap, and they may know many different things than you. But there's also stuff that you know that no one else does. So it is important to keep in mind that the fact that others are clever doesn't mean that they're, on average, that much better than you, or that you're much worse than them. It's just a matter of concentrating on your specialty and being able to produce on that area of research. Especially when you have a large group with lots of smart people, it's very difficult to make that distinction, because there's always going to be someone producing amazing research, and you'll have the impression that there's always someone smarter than you, but it's just the timing. So keep the hard work and concentrate on your research, and that will help your motivation. Okay, so what else is there? So a PhD project will likely be part of a collaborative research project. If there's IP worthy of patents, there's potential for knowledge transfer, that's collaboration with industries, or even creating your own startup. There's potential for industrial placements and improved career prospects. That's not only in the case of, IP worthy research, but it's particularly easy in those areas. So applied science tends to facilitate transition to industry, but not always. In general, the skill set of a PhD student, regardless of the field, is very attractive for the private sector. And this is, amongst other things, because you've been able to do that, 4-year motivation and hard working on multiple problems to solve a specific task. But if you want to experience what is it in industry, obviously go for internships. There's multiple opportunities, and as long as you get your support from your supervisor team, it's going to be possible. There's also a bunch of scientific events that you'll be attending regardless. These are conferences, seminars, workshops. We're going to be interacting with academics and scientists, and also industrial partners. And the good thing is that there's going to be free food in all of them, or at least free coffee. But the extra interesting thing is that is probably the best dissemination method for knowledge. Talking to others about the work they do beyond what published material can offer. And obviously in pre-COVID times, that would allow you to travel worldwide. And travel worldwide for a 2-day conference allows you to spend another 2 days visiting interesting cities and different cultures. So that's a plus that we expect to be recovering in the future. Now about thesis writing, I'm concerned that I'm running a bit low on time, but let's try to get through this. First of all,
I'm sorry to interrupt you. You are running over a little bit, so maybe if you could tie it up soon, that'd be great.
I will.
Awesome.
Thank you. So thesis writing, what is a story? You need to be able to produce that contribution to knowledge in a story format, and that should be easy to read for the assessors. The story will be impacted by the planning of the experiments, and for that you need to seek the supervisor's guidance, and that should reflect in the structure in the chapters. And you'll have to be aware that not everything you've done during your PhD will be put in your thesis. The people that are going to read the manuscript mainly and for sure are the proofreaders, so a team of people that are going to support you for free just to help you understand, improve the writing, and the assessors and examiners who are actually going to give you their professional opinion. It's very important to practice first, so write as many papers as possible. For that, seek the support of the supervisors, and it takes between 1 and 6 months to write on average, typically 3 to 4. Remember that you're going to be rewriting multiple times. This is part of the process, and this is a consequence of the fact that a manuscript is never finished, it's abandoned, because you can always improve what's written, but eventually you and the team of proofreaders are going to get tired of it. So that final .doc document will be rewritten multiple times until everyone is fed up with it and you run out of time. But that's fine, that's part of the process and everyone knows it. So what's next? You have to choose academia or industry. That's one of the routes, but this picture is relevant. It shows that not that many people stay in academia, and academia is actually not that great. It has its pros and its cons. So I encourage people to consider their careers early on to decide whether the skills that they're developing are the right ones. I'm probably going to skip through this because that's the whole point of careers in quantum, and just say thank you to everyone, and I'm ready to answer questions.
Awesome. Thank you for that very detailed and inspiring talk, Jorge. I know you've given me some of that advice on different occasions in the past, so it's nice to have it there in a fully complete form. Yeah, so we're running over a little bit, but I think we've got time for like one question, and I encourage people to put questions for Jorge in the Slack chat. But I think maybe a good question would be, and maybe I'll add to it, is from Tom. What are the metrics for a successful PhD? And maybe like what I'd add to it is, do those metrics change depending on industry or academia?
Yes, that's an interesting question. I would say the first metric is whether you're happy. Are you happy at the end of it? And that happiness comes from your expectations. So if you're looking to get a job in industry after you finish your PhD and a good salary, and that's what the PhD allows you to get, then it's a successful PhD, regardless of what happens during the PhD. Now, if you're thinking about, what would the recruitment team say if they look at my CV after the PhD? Well, if you want to stay in academia, typically you need to show that you've produced some new research and that research has been impactful enough. This is, again, motivated by luck and partially driven by the fact that there's existing projects led by your supervisor, but also shows how much work you've been able to put. So publications and conference communications and talks are probably the quick metric that people use in academia to hire people at the postdoctoral level. Beyond that is whether they have the right set of skills and expertise to help in the project that they're going to be doing. For industry, I would say I'm not an expert because obviously I'm not working in industry, but my impression is that the most important thing is to be able to show that you are able to complete projects from start to finish and that your contribution is significant and well structured. So you're able to keep your deadlines and you're able to do the tasks that you're asked to do, that you know your skills well and that you're independent. So often, if you are aiming to go to industry, it's more important to be able to develop those skills and to be able to structure your research in a productive way, rather than concentrating on a bunch of independently highly impactful papers. So it's slightly different, but ultimately, we're in a field in quantum that the transition from academia to industry is much easier than other fields at the moment.
Okay, well, thank you for that great answer. So we've run out of time now, so I ask everyone to put their questions in the Slack chat. But yeah, thank you again, Jorge, for this very very great talk, and appreciate you. You've helped us throughout the CDT, and given us this talk as well has been very valuable.